characteristics of a mineral. Go ahead and raise. Go ahead.
Color, luster,
Perfect. That's kind of how you test, how to determine minerals, that type of thing. What are some other ones?
Solid.
Yep, generally. Yep, so they're inorganic solids. Anybody else?
Naturally occurring.
Yep, naturally occurring. Did you have one?
And
Go ahead.
crystal structure.
Yep, they're crystal structures. Anybody else? Yeah, so the four kind of main things are that they naturally occur, they're crystal structures, they're inorganic solids, and then they have a definite chemical composition. And then from yesterday's lab, do you remember kind of what the objective of it was?
Identify minerals.
Yeah, kind of just define the identification of minerals. And then what were some of the things that you did? You kind of mentioned them already to help identify those minerals. Yep, so the streak. So how did you test streak?
you use the streak plate and you basically rub it on the streak plate.
Uh-huh.
And if the streak didn't show up, it was colorless. So it was too hard for the streak plate.
Very good. What was another one of your tests you did? The luster. And then what was luster? What was kind of with that? Anybody else? No? Anybody? Go ahead.
How it reflects light.
Yep. So it's going to be if it's like metallic or shiny, that kind of thing. And what was the last thing you did? Color. Anybody have color? That was the easy one. It's the color of it. So now go on your computers and you can go ahead and answer that question. So how do you test the hardness of a mineral? And it'll come up here. I think you need 17 answers. So how do you test the hardness of a mineral? Tap it with a mineral hammer, you do the field hardness test, you bite it, or you do the lab density test. So go ahead and click A, B, C, or D on your computer. Perfect, looks like we got everybody. Do you want to click the I thing? Alright, so this kind of tells us how we did as a class. Field hardness test is the correct answer. Most of you got that right, good job. Tap it with a hammer. Kind of right, but a hammer, you can hit a diamond with a hammer, and if you hit it right, it'll still crack, even though diamonds are the hardest mineral you have. So kind of varies there. And then lab density test, we're testing the hardness of it, not necessarily the density. So that was good. You can go ahead and shut your laptops now. We'll use them in a minute though. And then if you want to switch to PowerPoint. So we'll just start off reading. Do you want to start? And you'll just read this first one, our objective for the day.
After this lesson, students will be able to explain how minerals are identified.
Perfect.
Measure how easily a mineral can be scratched is its hardness.
Sometimes whether or not
That's kind of what we were talking about with that diamond thing. Make sure you speak up when you talk so everybody can hear you. And we'll kind of go over this list here later, but the Mohs scale goes through like the minerals that you're testing. This is the hardness of common objects. So these things are things that you're generally going to be able to find pretty easily. Your fingernails, hopefully they're there all the time. Next one.
This list is called Mohs scale. Not all mineral crystals have smooth surfaces and regular shapes.
There are 6 major crystal systems which classify minerals according to their crystal structures.
So we'll go through these here.
Minerals in the cubic crystal system are equal in size along all 3 principal dimensions.
So the cubic one is cube.
Tetragonal crystals are much like cubic crystals except that one of the principal dimensions is longer or shorter than the other 2 dimensions.
So kind of like 2 cubes stacked together.
In hexagonal crystals, horizontal distances between opposite crystal surfaces are equal. These crystal surfaces intersect to form 60-degree or 120-degree angles. The vertical length is longer or shorter than the horizontal length.
So this one's going to have 6 definite flat sides that you'll see.
Minerals with orthorhombic structure have dimensions that are unequal in length, resulting in crystals with a brick-like shape. Minerals in the monoclinic system exhibit unequal dimensions in their crystal structure. Only one right angle forms where crystal surfaces meet. The other angles are oblique, which means they don't form 90-degree angles where they intersect. Triclinic crystals are unequal in all dimensions, and all angles where crystal surfaces meet are oblique.
So you'll see with like the triclinic one, pretty easy to remember triangle, triclinic, you're going to see a triangle in there. Go on here.
Another way to add minerals is through the breakage.
The way a mineral breaks is another clue to its identity.
Minerals that break onto that surfaces have cleavage.
Cleavage is determined already by the determinants of minerals and things.
Not all minerals have
Minerals that break with rough or jagged surfaces have fracture.
Yeah.
quartz is a mineral with fracture.
Yep, so why don't you, the first row, turn and talk to the second row. Third row, turn and talk to the 4th row. You can go ahead and join this group over here. So talk with your partners, kind of compare and contrast the differences and similarities between a cleavage and a fracture. Alright, you guys get it? Who wants to share a difference between cleavage and fracture?
So cleavage is basically, if it splits, it'll be a smooth surface, but fracture, if it splits, the surface will be jagged and rigid.
Yeah, so like a cleavage is going to be this one where you can feel it's a smooth break and it's kind of just like a flat thing. It'll come in kind of sheets, kind of like this. A fracture is going to be a little more jagged. You're not going to find a very smooth surface on here. So if you, for example, this one, if you were to drop this, it wouldn't split into perfectly straight sheets of mineral. It would break into thousands of little fractured pieces. So we'll pass these around real quick. The flat one's the cleavage and this one's the fracture. And then I think we're here for the
Some
reading.
minerals have unique properties.
We'll go back. Well, we'll start at the beginning here now. Magnetite. Yep, so magnetite is going to be this. It's also called lodestone. And this is going to be your only rock in your lab that you do that's magnetic. So on Monday when you do your lab, there'll be some staples in your hardness kit. So if you take all of your minerals and put them in here, the only one that's going to pick up the staples like this is going to be your magnetite or your lodestone. So that's going to be a pretty easy one for you to find because it's the only one that'll do that. And then smell is another way that you can identify these, and all of these things are things that you'd like to write on your paper when you're doing your identification. So if you identify it and you think, oh, this one picked up staples, then you write that down and say it's magnetic, because that'll help you identify later on. So for smell, this is sulfur, and sulfur is kind of like, have you ever been to Yellowstone National Park? You know that smell that's there, or the smell of fireworks kind of? That's what this smell is. Gotta freshen it up a little bit here. And this is a really soft mineral too. So we'll pass this around, you can give it a smell, and you can really easily smell that sulfury smell. So that's another way to help identify what minerals you have. And lastly, another property is the fluorescence of it. So some minerals, if you put them under a black light, are going to glow. So like these ones here, we'll look at them right now. They look like pretty normal minerals, right? Nothing too special about them.
Yeah,
Look pretty good.
You never know.
Good things are hard, huh? So then we'll take the black light over here. You see that, how different they are?
Whoa, what's that one?
So they look a lot different when you put a black light to these ones. So that's another way to help identify. Yeah. And then the last main property is for quartz. I think we're, so in your lab yesterday, you had quite a few transparent minerals, right? But there's only one, which is calcite, that's going to make you see two when you look through it. So that's another one of those easy ones, like lodestone when you do your test on Monday. The only transparent one that you look through and it's going to be double is going to be calcite. So that's another kind of gimme one. And then if you want to open up your computers again, and go to kahoot.it. It'll be right here. So we'll go to. And once you get to Kahoot, go ahead and enter that game pin, that 823213. And once you enter the game pin, it'll tell you to enter a username. Go ahead and put whatever you want in there. Just make sure it's appropriate, because if it's not, we can find you. Go ahead.
Oh,
823213. Not working? Here, let's see here. Technical difficulties. Here, let's try it now with that new game pin. 279722.
Yep.
That one's working?
Yep.
Alright, so you'll enter your username, then you'll come to a green screen that says got it, or ready, or something like that.
Got it.
Screen up.
We had 17, right? Yep, so make sure it's appropriate.
Hey, there's it. All the way.
Okay, we're waiting on one. Does everybody got it? There we go.
Yeah.
Alright, so has anybody done a Kahoot quiz before?
No.
No? Okay. So with this, once we push start, it's going to come up with a question up here, and you only have 20 seconds to answer it. You're going to have to look at the big screen here, because there's going to be 4 answers that have a color and a shape with it. And then on your screen, all you're gonna see is a color or a shape with it. So you're gonna have to correlate the answers from the screen with the colors on your page. And you get more points the quicker you answer.
Big fish.
Only if you answer right though. So get it right and get it quick and we're ready to go.
Wow.
So I'll read the question for you, then you'll be on your way. So which of these is a characteristic of minerals? Crystalline solid, formed by life processes, indefinite chemical composition, or organic substance? We got 11 seconds left. There we go. Correct answer is a crystalline solid. Most of you got that right. We know that it's not formed by life processes. It's an inorganic substance. And it's a definite chemical composition. It's not indefinite. So that was good. Ready for the next one?
Yeah.
Alright, ready? Okay. So whoever that is in first place, but
Who is
it is right behind. So,
Who is it?
alright.
Who's anonymous?
The Mohs scale uses what to compare minerals? Cleavage, color, hardness, or luster? Got one left.
Let's answer.
7 seconds to click. There we go. Correct answer is hardness. Good job. Everybody got it right. That was great. Alright. Still got the same order there, although we got a tie. Minerals that break easily along smooth, flat surfaces have what? Cleavage, fracture, luster, or streak?
God, I missed that one question. Got me messed up.
There we go. Good job. I think you're the first class to get